Okay, this is exam 4, question number 3. Let F be the relation such that for all ordered pairs xy in the reals, x is related to y through f if and only if x times y is greater than or equal to 0. And we're being asked if the function f is reflexive, symmetric, and transitive. So as usual, I will just write down a couple small notes that x is related to y through f if and only if x times y is greater than or equal to 0. So I want to get some intuition about what acceptable values there are here. So I'm going to start, and 0 seems pretty important because it's sort of, we have the 0 rule, or 0, what is it? I forget the name of it, 0 product property, I think it's called. So there's some, let's just center sort of our attention around 0 and see if we can get an intuition. So what happens when x is greater than 0? For instance, x is 1. Well, what values can y be equal to so that it's still greater than or equal to 0? Well, how about y is equal to 1? Sure, because 1 times 1 is greater than or equal to 0. Well, what about 0 itself? So let's try 0. And so 1 times 0 is 0, which is still greater than or equal to 0. So when x is greater than 0, y must be greater than or equal to 0. Okay? Well, what happens when x is less than 0? For instance, negative numbers, right? So we could have x is equal to negative 1. What happens if I do y is equal to 1? Right, so that's negative 1 times 1. Is that greater than or equal to 0? It sure is not, because negative 1 is actually less than 0. So y cannot be 1. So let's try x equals negative 1 and y is equal to 1. I'm sorry, negative 1. Because a negative times a negative is a positive. So let's do negative 1 times negative 1. Is that greater than or equal to 0? It sure is, because 1 is greater than 0. And let's just do one more little test. How about x equals negative 1 and y is equal to 0? Right? That's sort of our special number in this problem. Well, negative 1 times 0 is equal to 0, which is greater than or equal to 0. Right? So through sort of trial and error, I'm sort of getting some properties of this problem. So when x is less than 0, y must be less than or equal to 0. I've tested for all positive numbers. I've tested for all negative numbers. Now let me just test for x is equal to 0. Okay? So x equals 0. Let's try y is equal to 1. Well, 1 times 0 is 0, which is greater than or equal to 0. So that works. So it can be positive. Need to catch up. All right, so x equals 0. How about y is equal to negative 1? Well, negative 1 times 0 is still equal to 0, which is greater than or equal to 0. And let's try our special case. How about y is equal to 0? Well, 0 times 0 is equal to 0, which is greater than or equal to 0. So it turns out that y can be an element of any of the real numbers. And this is the case that we want to really look at. There we go. Because it turns out that when x is equal to 0, y can be positive or negative, and that would be important later on in this problem. Okay, so now let's start answering some questions. Is f reflexive? And so just to remind you what that means, if f is reflexive, that for any x, I can relate it back to itself, like so. So for instance, can I relate 1 to itself? Sure, 1 times 1 is 1, which is greater than or equal to 0. This is true for any value of x. And we sort of can tell that by looking at this little chart that we've created. X is greater than 0. So for every positive value, I can pick a y that's the same value. Same thing when it's negative, right? And even when it's 0, well, 0 isn't the real number, so it could be equal to itself. So the answer to A is yes. Well, how about is F symmetric? Well, F is symmetric. So if X is related to Y through F, then Y is related to X through F. In other words, the order doesn't matter. Well, our key for this is that X times Y, right? Now we all know that X times Y is equal to Y times X. In other words, the order doesn't matter. So I would say yes. And if I was pressed for a reason, I might say the cumulative law of multiplication. And that just is the fancy way of saying that it doesn't matter what order you multiply things in. And our last question is F transitive. This is the hard one of this problem. It's kind of a gotcha. As I mentioned, when X is positive, Y is either 0 or positive. When X is negative, then Y is either 0 or negative. But when X is 0, Y can be any number. So to remind you what the transitive relationship type is, if we're given that X is related to Y through F and Y is related to Z through F, then X must be related to Z through F. And so how I internally conceptualize this is it's sort of like taking a shortcut, right? So I'll give you an example. 1, 3 is an element of F. 3, 7 is an element of F. Then we need to test that 1, 7 is an element of F. Where am I getting 1, 7? It's my first one here and my last one here. I sort of picture it as like it's skipping the 3. It's a shortcut. Well, it turns out for this problem that we can fashion a counterexample that proves that it's not transitive using this third property in our little table here. So as an example, what if I started at negative 1, 0? Well, negative 1 times 0 is equal to 0, which is greater than or equal to 0. So this checks out. And how about 0, 1? Well, 0 times 1 is equal to 0, which is greater than or equal to 0. So that checks out. However, is negative 1 1 in the relation? Well, negative 1 times 1 is equal to negative 1, which is not greater than or equal to 0. And so how I would word this on the test is I would say no, F is not transitive because negative 1, 0 is an element of F and 0, 1 is an element of F, but negative 1, 1 is not an element of F. That's it for this question.